So you want to know what a supercell is. Supercells are some of the most powerful and dangerous thunderstorms on planet Earth. They can produce giant hail, destructive winds, and strong to violent tornadoes. But what exactly makes a storm a supercell? Today we're breaking down how supercells form and the basic anatomy of these wonders of nature. A supercell is a thunderstorm with a rotating updraft. This updraft is called the mesocyclone. Unlike ordinary thunderstorms, supercells are highly organized and can survive for hours. I even chased some myself. Here's a time-lapse of a supercell I saw on April 24th this year. One of the driving factors of this storm is, you guessed it, wind shear. Wind shear is when the wind changes with speed and direction the higher you go up in the atmosphere. Near the ground, the winds are usually southerly or out of the south, while higher up, say at about 500 millibars or in the mid-levels, they are usually from the southwest or southwesterly. This creates horizontal tubes of spinning air in the atmosphere. And once you get an updraft to tilt that rotation, that can become a supercell. But as you might guess, wind shear is not the only factor to supercell development. Supercells also need warm, moist air and cold, drier air aloft. One weather parameter that relates to this really well is called lapse rates. Lapse rates are a measure of the temperature in degrees and Celsius for every kilometer you go up in the atmosphere, depending on different levels of the atmosphere. This provides the cold air aloft needed for supercell development. One rule with meteorology is that a warm air parcel cannot rise unless the air around it is cooler. Lapse rates can help with this. Not every supercell is the same. There are 4 types of supercells, those types being classic, LP, HP, and mini. A classic supercell has a rain-free updraft base and a rain core shunted away from the updraft quite a bit, but still lots of heavy rain. An LP supercell has little to no precipitation and are typically very photogenic, but are actually, surprisingly, least efficient at producing tornadoes. HP supercells are completely shrouded in rain. All of their important features are completely covered in rain and are the most dangerous storms to chase because tornadoes are typically hidden behind walls of rain and hail. And while I don't have any pictures of a mini supercell is usually just a very low-topped, smaller than average supercell. If you've watched a lot of weather videos, there's a good chance you've seen radar imagery of a supercell. I made a little graphic for y'all, both on reflectivity and velocity. Reflectivity shows precipitation and the intensity of the precipitation. Blues and greens are light rain. Yellow and orange rain are moderate levels of rainfall, while dark red and pink usually indicate either very heavy rain or large hail. On velocity, green means the winds are going toward the radar, and red means winds are going away from the radar. And since in the northern hemisphere, supercells rotate counterclockwise, by looking at that blue next to that red, you can tell that that's the supercellular rotation with this specific example. Other than a rotating updraft, supercells have some other characteristics. These characteristics being large hail, damaging winds, frequent lightning, wall clouds, and tornadoes. If you would like to know the different types of tornadoes, check out my video about tornado types. But those are for another video. If you enjoyed this video, please be sure to give a like and subscribe and maybe a comment. This video took quite a while to make. I hope you enjoyed it, and I'll see you in the next one.